Based on the climate zone mapping and temperature accumulation, the frost risk is minimal.
The genetic vigor assessment aligns perfectly.
We need to ensure this supports the long-term stability model.
The current data validates the erosion control measures.
Soil
Organic matter evaluation is finalized through laboratory and field correlation studies, resulting in confirmation.
Operation 6. Microbial soil balance is enhanced through pre-plant plant sanitation and ability.
Operation 7. Sunlight exposure modeling is refined using row-oriented optimization simulations to predict
integrating soil profile analysis, climate zone mapping, and drainage data to finalize the suitability zones.
The mitigation strategy addresses the erosion concerns.
Good. We need to ensure alignment with the zero incident mindset before we finalize the land prep design.
Compaction layers eliminated as projected. Validate the spacing metrics.
Spacing is uniform. Microbial balance remains stable according to the telemetry.
Surface deviation is nominal. The grade is holding steady across the plane.
Looks perfect. Proceed with the run.
The hydration levels are stable here.
Good. The screening is effective. Let's verify the depth control.
Operation 14. Soil aeration optimization is refined through secondary tillage and surface conditioning to balance oxygen exchange and moisture retention.
Compost integration is found. Organic compost performed using controlled nutrient analysis confirms the soil chemistry is aligned.
Ready for planting layout implementation? Then.
The pathways are clear, ensuring we maintain cold chain continuity and emergency access. The field is fully prepared.
Operation 18. Machinery access lanes are established to allow safe movement of automated equipment during planting,
Operation 20. Stage 2 concludes with comprehensive pre-plant sanitation of the entire field.
Operation 11. Land preparation begins with deep soil ripping, executed by automated agricultural.
The elevation on grid 4 is stabilizing right at the target gradient.
Confirmed. We are within the parameters for the irrigation plan.
Soil aeration optimization is refined through secondary tillage and surface conditioning to balance oxygen exchange and moisture retention.
Operation 15. Organic compost integration is performed using controlled distributions.
Operation 16. Baseline nutrient calibration is verified through in-field sampling and rapid analysis.
Operation 19. Erosion control contouring is finalized by shaping land.
Operation 20. Stage 2 concludes with comprehensive pre-plant sanitation of the entire field.
Stage 4 optimization is complete.
The new alignment maximizes sun interception balance.
Operation 33. Canopy airflow modeling is further refined by simulation.
Operation 34. Sun interception balance is validated by cross-referencing seasonal solar angles with proposed row spacing and canopy height assumptions.
Operation 6.
Operation 37. Soil compaction avoidance zones are designated by mapping machinery access lanes.
Operation 38. Root expansion allowance is confirmed by validating subsoil conditions and spacing. The grid is finalized. We can now link the soil data directly to the spatial reference system.
Operation 40. Stage 4 concludes with planting line marking using durable, field-visible indicators aligned with the approved layout design.
Operation 42. Planting depth control is executed using calibrated planting equipment that ensures each.
Operation 43. Crown positioning accuracy is verified manually and digitally to ensure that.
Operation 44. Soil backfill compaction is performed in controlled stages to secure root-to-soil contact without eliminating necessary pore space.
Operation 45. Initial vine anchoring is carried out by securing young plants to temporary supports that prevent wind displacement.
Operation 46. Moisture retention layering is applied at the soil surface.
Operation 47. Plant stress minimization protocols are implemented immediately after planting through controlled irrigation pulses and environmental.
Operation 49. Growth alignment correction is performed by visually inspecting each vine and adjusting orientation to.
Stage 5 concludes with early survival monitoring, consolidating planting data into USDA compliance documentation.
Operation 51. Stage 6 begins with trellis load engineering, where structural calculations are performed.
Galvanized wire tensioning is performed using calibrated tensioning systems to achieve uniform load distribution across all rows, preventing sagging or uneven stress.
Operation 54. Vertical shoot positioning is initiated by guiding young vine shoots along the trellis system to establish controlled upward growth. Operation 55. Trunk formation guidance is applied through selective shoot retention. Operation 56. Growth direction control is refined by adjusting ties and supports to prevent lateral. Operation 58. Long-term stroke stability is verified through inspection of trellis components, wire tension, and.
Operation 59. Equipment clearance design is confirmed by testing machinery movement beneath and between trellis rows, preventing.
The vines are evaluated for consistency in height, alignment, and attachment to the trellis system. Consolidate. Operation 62. Nutrient uptake balance management is implemented through controlled fertigation programs that integrate baseline nutrient calibration data.
The leaf analysis shows we need to fine-tune the strategy for these clusters.
Agreed. We need to ensure uniform vine architecture across the blocks. Operation 4. Nitrogen control is defined by adjusting application. Operation 66. Growth stage specific feeding is executed by synchronizing nutrient delivery muffins. Stress response monitoring is continuously performed using visual inspection, sensor data, and growth indicators to.
Operation 69. Color development consistency is indirectly supported by maintaining balanced vegetative growth that ensures uniform light distribution.
Operation 70. Stage 7 concludes with vine vigor regulation verification, where.
Operation 71. Stage 8 begins with the execution of a dormant pruning strategy designed to reset.
Operation 72. Bud load management is applied immediately following pruning by quantifying.
Operation 73. Spur positioning accuracy is refined by adjusting the spatial distribution.
Operation 75. Flower cluster regulation is initiated by evaluating early bud differentiation and.
Operation 76.
Energy redistribution within the vine is actively managed. Operation 77. Canopy density control is achieved through selective shoot thinning and positioning to maintain optimal airflow and light penetration. Operation 78. Uniform bloom timing is reinforced by synchronizing pruning intensity and shoot.
Operation 79. Disease risk reduction into pruning and flowering.
If we adjust the bud load here, we ensure optimal flowering potential for stage 9.
Absolutely, the uniformity of
Operation 81. Stage 9 begins with berry size optimization management, where developing grape berries.
Cluster airflow spacing is refined by selectively adjusting shoot positioning and removing obstructive vegetative growth around fruit zones. Operation 83. Sunburn prevention measures are implemented through controlled canopy shading techniques that regulate direct light exposure during peak radiation periods.
Operation 86. Sugar accumulation control is managed by regulating irrigation input and leaf.
The color uniformity profile is excellent across all blocks.
Confirmed. We are ready for harvest planning.
Operation 88. Fruit integrity protection is reinforced by minimizing mechanical contact and vibration near.
Operation 89. Operation 8 distribution balance within clusters is a valid stress to its non-label.
Operation 90. Stage 9 concludes with comprehensive pre-harvest quality checks that consolidate data on
Berry size and color uniformity are excellent on this cluster.
Agreed. The harvest schedule is officially approved.
Operation 92. Brix level measurement is executed systematically using calibrated instruments across representative sampling zones to confirm internal sugar concentration consistency.
Operation 9094. Field sorting protocol is implemented immediately after cutting to separate non-conforming clusters.
Operation 95. Rapid field cooling is performed using mobile cooling units. As part of Operation 97, we use only approved food-grade packaging. Notice how the vents ensure airflow. Operation 98. Traceability labeling is affixed to each packaged unit, linking harvest date, vineyard yield.
Operation 99. A post-harvest quality audit is conducted through inspection, sampling, and
An auditable system certifies the grapes as market-ready finished products with uniform color, verified safety.